In the last video we have finished implementing pattern manager class, and now we will need to go through the pattern finder class, and we will see this new slide. So let's go to the pattern finder class and let's start implementing it. Okay, let's place it in our namespace and delete the monobehavior inheritance. Remember to leave those two methods. Okay, so we need to make this class static. And basically this class will have logic to find patterns and then to use strategy to find neighbors for all the patterns it have found before. Okay, so let's implement the get pattern data from grid. This is this method that we have created previously, and we will call create here two dictionaries, one that takes string and pattern data, and it will be called pattern hashcode dictionary. And the second one will be pattern index dictionary that takes int and pattern data. So basically, to find unique patterns, we will calculate their hash code and add them to the pattern hashcode dictionary, and later add those to the int pattern data dictionary, so pattern index dictionary, and we will return pattern index dictionary. Okay, we need some more fields here. We need vector2 size of our grid, and it will be get it from value manager get grid size. And we need to implement this method, so let's go to generate method. Let's go to it. And here we will check if grid is different than null. If it is null, we will return vector2 0, as vector2 cannot be null, and else we will return new vector2, and we'll take grid 0 length and grid length. Okay, great, we can go back to the pattern finder. Okay, now we need to create a pattern grid size for x-axis and y-axis. So let's create two values of integers pattern grid size x and y. And as you might remember, we have discussed that pattern grid size might be different than value grid size. So I think we need to go back to slides and discuss it a little bit. On this slide, if we have a pattern size of 4, we have this square as one pattern, and then we move one cell to the right and take another square of 4 by 4 and go further until we reach the last column of our value grid. And here we have pattern grid size of 7 by 7 if we calculate 1, 2, 3, 4, 5, 6, 7. But for pattern 1 and 2 we have the same value grid, thus pattern of size 2 has a smaller grid than pattern of size 1. So this is the main reason why we need to calculate it differently if the pattern size is more than 2. So let's get back to code. Okay, first we need some integer values for row min, row max, col min, col max. Okay, and now we need to make the calculation of the pattern grid size. So we have two cases, if pattern size is smaller than 3 and otherwise. Okay, in the first case, we will have a calculation for pattern grid size that it's the grid size plus 3 minus pattern size. So let's create it for both x and y. We'll cast it to int size of grid that we have retrieved from value manager dot x plus 3 minus pattern size. The same for y. And we can make row max and col max equals to pattern grid size minus 1. So row takes pattern grid size y and col takes pattern grid size x. And this calculation only works for pattern size 1 and 2. For others, we have a different calculation. So the same pattern size x equals, and we now add size of grid x plus pattern size minus 1. The same calculation applies for y-axis. Okay, and now we need to change the row min and row max. As you have seen on the slide, when we have pattern of size greater than 2, we are starting far behind the point 0, 0. That's why we need to set row min and row max and col min appropriately, and col max and row max will always be the size of our grid of values. So let's create it, row min and col min. And we'll make it 1 minus pattern size. 1 because size that starts counting from 1, and we are talking about index, so row min represents the index, so it starts calculation from 0. That's why we need 1 minus. And for row max and col max, we will set it to the size of the grid with appropriate axis. So for row we will take y, and for col we will take x. Okay, so now we should have correctly calculated pattern grid size. Now we need to create our placeholder for jagged array of integer values that will represent our pattern indices grid. So let's create our pattern indices grid jagged array of integers. We'll use my collection helpers, actually my collection extensions, and we need to import using helpers. Create jagged array, integer jagged array with 2 spaces, and we'll pass it pattern size y for rows, and pattern size grid size x for columns. We need 2 more values, int total frequency and int pattern index. So total frequency will be used for further calculations of frequencies for each pattern. So if we know the total frequency, then we can calculate the partial frequency or relative frequency, as you have called it, and the logarithm of frequency for each pattern. And pattern index will be used to map each unique pattern to an index. Now we will have to loop through row min to row max, col min to col max, and create our patterns. So let's create a loop. Okay, now we have our loop, and we will need first to create a grid of values. So let's create an int jagged array, and grid values are the values that we extract from value manager depending on the pattern size. So we'll call value manager to get pattern values from grid add. We will pass column, row, and pattern size. So this grid is filled with values that will be stored in our pattern. Next, we will need to calculate the hash value for this grid. And we have our hashcode calculator in our helper namespace that I have provided with the basic project. And we'll call on it calculate hashcode grid values. Okay, we can visit this class. This class is implemented from the Microsoft support page for how to compute and compare hash values. So basically what we are doing here is taking our grid jagged array of integers, converting it to byte array, computing the hash code from it, and using the hash code to check if we have this value array inside our dictionary or not. So because a hash code is unique for different objects, we can check if we don't have the same values inside our grid, the same combination of values that we already have previously classified as a pattern. So let's implement the further code. Basically, we will check against our pattern hashcode dictionary, so the dictionary that takes strings and pattern data. So let's create the if statement. So if our dictionary contains key, our hash value, so if we don't have it, we'll create a new pattern, add pattern index, and add a new pattern to our dictionary. So as you might remember, our pattern takes values grid, hashcode, and index. So we'll pass our grid values, our hash value, and our index that we will be increasing. Now we will increase pattern index as it is a global variable, and we will use a helper method to add the pattern to the dictionary. It will take dictionary, index dictionary, hash value, and our pattern. Okay, let's create a placeholder for this method. And else, if equal weights equals false, we'll add to our pattern index dictionary, and we'll add to frequency of the pattern. So we will access the index of our pattern, so the key, by finding it by hash value inside our pattern hashcode dictionary, accessing the pattern and its index. So therefore we have the key for our pattern index dictionary, and now we'll call add to frequency. Actually, we could have called this same method on our pattern hashcode dictionary. So let's go to our add new pattern method. So here we need to create pattern data, and it takes pattern as an input, and we are passing pattern as the parameter for this method, and we'll call pattern hashcode dictionary add hash value and the pattern data, actually the data object, and the same for the other dictionary of the index dictionary. Okay, and that's it for our add new pattern. So basically what we have done here is we have looped through each possible pattern, and we have taken the values from the offset and from the original value grid, and we have created the patterns based on the grid values. For our pattern size 1, it will be one value. For bigger patterns, it will be a jagged array of values. We are calculating the hash value so we don't create two patterns that represent the same grid values jagged array, and we add those to the dictionary. So last step is to calculate relative frequencies, because we have now the total frequency. Actually, we don't have, we need to add to it. So we are always adding to total frequency, and now there is one other thing. So we need to add our indices to our pattern indices grid. But let's look at it. In the first example, it's all good because we are starting from -1, so we just add 1 to the row and column values, and we get 0 and up to the end of our pattern indices grid. But here we are starting from a negative value, so we have to change a little bit the calculation of the place in the pattern indices grid where we can place our index of our pattern. So let's see how we deal with it. We need to create an if statement to check if the pattern size is smaller than 3 or else. Okay, so for pattern smaller than 3, it's straightforward. Pattern indices grid, we call row +1 and column. Okay, we are making this, creating this in the wrong place. Need to be inside this for loop. Okay, now it's all good. And we assign it to pattern hashcode dictionary, pattern hash value, pattern index. Okay, in other case, we need to add to row and to column pattern size and decrease 1 to get the valid coordinates. So let's do this now. So row plus pattern size -1, and it will be equal to the same as above. Okay, great. And now we can go back down here and calculate the frequency, relative frequency, pass a pattern index dictionary and total frequency. So basically in this method we'll loop through each pattern and calculate and call it to calculate its total frequency, its relative frequency and logarithm, and we will return new pattern data results, pattern indices grid, and pattern index dictionary. Let's create the constructor. So basically, after calculating all the patterns, or after finding all the patterns, we will need to calculate the relative frequencies to get it out of the way, and then we'll return pattern data results, a class that will contain pattern indices grid and pattern index dictionary that will be further processed by the pattern manager. Okay, so let's get back to pattern data results class. And we can see that there is a lot to do. Mainly, we need to place it in our namespace and delete the monobehavior inheritance. So let's do it. We can delete using wave function collapse. Okay, so we already have here an integer jagged array pattern indices grid, and a constructor that we have created previously that takes in the pattern indices grid and the dictionary. So we also need, we have the dictionary as a property here, and let's create a private set. Okay, so next we will need some helper methods. Since this class will hold the mapping for each pattern, so we have this dictionary that will store the mapping for integer and pattern data. So we need other methods to be able to get data from this class. So let's implement getGridLength in X and getGridLength in Y methods. Both will return integer values. So let's create the X one. And we'll return the pattern indices grid length of 0th element. And let's do the same for Y direction. Here we'll return the length of the rows of pattern indices grid. Next we will have to implement getIndexAt that takes X and Y integers as coordinates and return an int value, so the index of the pattern. GetIndexAt takes int X and int Y, and we will return pattern indices grid X YX position. Okay, and last method is getNeighborIndirection. It will take X and Y coordinates and the direction and return integer value for the neighbor. So method is called getNeighborIndirection. It takes X, Y, and direction, and we will use an if statement to check if our index is valid. And for that we will use our extension method that we will create. So we call if statement on pattern indices grid, and we'll check if we will need to be using helper methods. So let's call it here helpers, and here we will use check jagged array to if index is valid. Okay, and we pass it x and y coordinates and check if it is equal to false. Okay, and let's create the rest. Okay, this is it, and this will return -1, so there is no index. Let's go check how this method looks. So here we take this generic jagged array, so that's why it is an extension method. It also takes coordinates x and y. If array equals null, it returns false. If it's true, we validate coordinates. So we pass x and y, so coordinates, and length and width, and height and width. And here we just perform a simple check. So if the coordinates are within the array. So you might imagine there would be many places where we could call the same method to validate the coordinates. That's why we have created a helper method, exactly extension method, to do it for us. So let's get back to code. So back at the pattern data results. So we will use a switch statement for direction again. We'll pass dir as direction and go down, and we will have a pre-created switch statement. And here we will only check again if a jagged array to if index is valid for each step, for each index, and if it is, we will return the neighbor. Since we will want to get the neighbor in their direction, if we need to check if the cell has the neighbor in this direction, and if it has, we will return it. If not, we will return -1. So let's create if statements. So again, we will call pattern grid, check if jagged array if the coordinates are valid, and up direction we will simply call x and y +1, and we will do the same check for with accurate x and y in every direction. If it is valid, we'll return get index at x and y +1. Let's copy this statement, and here we'll want, instead of breaking, return -1. And now let's copy this statement in each position. For the default, we want to return -1, and we will be changing those to -1 for down, and here in left we want to get -1 and -1 in the check, and for right we want to x +1 and x +1, and delete the +1 in y direction. And with this, our pattern data results is done. So to summarize, pattern data results class is going to store our results from the pattern finder, exactly the pattern grid and the pattern index dictionary that stores mapping for each pattern. Now we will get back to pattern finder and implement the remaining methods. Let's start from calculate relative frequency, and here we'll call for each on our dictionary that we have passed in here, pattern index dictionary, and also we'll go through the values and call item.calculate relative frequency that we have created previously and pass it total frequency. Okay, let's now implement find possible neighbors, and this method will simply call this strategy, and it will call find neighbors and pass pattern finder result. So let's create the placeholder for this method. We will soon go to iFindNeighbor strategy and create this class, actually this interface. Okay, so let's create let's finish the pattern finder class. We will need a check neighbors in each direction method that will be static, and we'll return pattern neighbors. And we will take X and Y coordinates and pattern data results. Okay, and now in this method we will loop through each direction, get the neighbor in this direction from our grid, and then we will create the neighbors in each direction and return it as a pattern neighbor. So let's create a new pattern neighbor instance, and we don't pass it anything. Let's call for each every direction, and to loop through enum we call enum.getValues and pass it type of and pass it direction, so the enum type, enum name. Okay, and now we will be looping through the enum, and we will create integer possible pattern index, and here we will call our method that gets the neighbor if they exist. So we will call get neighbors in direction and pass it X, Y, and direction. Okay, and here we need to rename it to dir. Okay, good. And if the result is greater than 0, so it exists, we will add it to our pattern neighbors. Let's change the letter to lowercase. Possible pattern index is greater than 0. Pattern neighbors, add pattern to dictionary, and we pass direction and possible pattern index, and we need here to change it to specifically call direction. Okay, and we will return what we have, pattern neighbors. Okay, good. And we will need another static method called add neighbors to dictionary, and it will take dictionary of int pattern neighbors, int pattern index, and pattern neighbor. We will call it dictionary, int pattern index, and pattern neighbors. Here we will simply check if a dictionary contains key. If it doesn't, we will add this pattern index and neighbors and pattern neighbors. If it doesn't, we will just concatenate the neighbors so this is the case where we have multiple instances of the same pattern, and we add the neighbors for each instance into the mapping dictionary. So the index tile with index has all the neighbors for all the instances as their possible neighbors. Okay, so let's create the check. If dictionary contain key, pattern index equals false, we will add the index and neighbors to the dictionary. Otherwise, we will concatenate the neighbors. Okay, and that's it. Believe it or not, we have finished Pattern Finder class. So I believe we will stop here, and in this next video implement the Pattern Finder strategies. So see you there.